kids. Hey, we are going to be talking again about conservation of momentum. So let's first talk about this. Hey, if I have a red ball and a green ball, and they have the same exact mass, if I click on center of mass, remember the center of mass is the center of the system's mass distribution. Well, if they're exactly the same, if I click on it, whoa, it's right in between. I know, what a surprise. But if I change this so that I have, hey, let's make the green ball have more mass. What? The center of mass moves towards it. In fact, if the green one has twice as much mass as the red one, the center of mass is, this distance would be 1/3. This distance would be 2/3 of the whole distance because it'd be twice as close to this one. But whoa, look at that. Ooh, wow. That's really exciting. All right, anyway, so we'll go back to 1 and 1. Does that, hopefully that makes sense. I am also going to say, hey, I want this one to have a velocity of 1 meter per second. I want my elasticity to be 0. And so we're going to do this problem. So hopefully you should have already worked out this problem. Draw your before-after picture, solve it. But then if I hit run, here's the part that's pretty cool. So I'm going to hit run and doink, they both move together. But if I hit restart, so I want to restart it like it was. So let me move it all back to how it was. This one's 1. This one is 1. My elasticity is 0. This has a velocity of 1. Okay. Watch the center of mass, though. So here's my center of mass, and I'm going to hit play. If you notice, if you're watching that, you will see that the center of mass its velocity stays exactly the same the whole time. So watch it again. You can see, move, 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 move. It just moves along at a constant velocity. That's pretty cool. I know. All right, so let me hit restart, and now we're going to try the other situation. So you guys are probably going to pause the video, do your work, answer your questions, and then when you get to the last situation where this one is going to be 0.5, and this one is going to be 2 kilograms, and this one is going to have a velocity of 1, and this one's going to have a velocity of negative 0.25. Okay, so here's our situation. And this time I want it to have an elasticity of 100%. Everybody see my center of mass? Well, actually, first we're going to run it without the center of mass. And I'm going to hit run. Everybody ready? So I'm going to hit run. Ooh, boink. Pretty exciting. I know. Well, if you would have worked it out, hopefully you have worked it out. So let me hit reset again. So let me reset everything. So this is correct. That's correct. But this time I'm going to click on the center of mass. And if you hit run, watch the center of mass. Ready? Whoa, the center of mass doesn't move. So cool. Why? Because the total, if I hit restart, if I look at the momenta, here's the momentum of ball 1, here's the momentum of ball 2. Well, the total momentum cancels out. In fact, I could have whatever elasticity, and if you watch this center of mass, if I hit run, it doesn't move. Man, great stuff. Remember, center of mass is sometimes a really, really nice way of explaining things. Why? Because it's a single point that represents the whole system. Bye, kids.